So thank you, Rapsa, for the second episode. So ngayon, we'll go to the third episode na of our Pulmophysio Crash Course, which is about lung mechanics. So medyo mahaba yung discussion about this sa lecture natin, but I tried to compress them all. And hinanap ko lang talaga yung mga important stuff na kailangan natin sobrang maintindihan. Okay? So the general objectives of these review is to list down the functions of the respiratory system, to point out how the anatomic and biochemical properties of the respiratory system facilitate gas exchange between man and his environment. Third, to understand the statics and dynamics of breathing. And lastly, to review physical laws governing gas exchange. Okay, so let's start. So ano ba yung functions ng respiratory system? So first is gas exchange. That's the most important function of the respiratory system. Next is heat exchange. Ito yung mino-moisten and yung mino-warm in air na ini-inspire natin. Third is your blood gas homeostasis. This acts as a buffer system and allows acid-base balance, which will be discussed in another episode. Next is phonation. So our larynx is mainly responsible for that. Defense. So our respiratory system is lined mostly by respiratory epithelium, which acts as a physical barrier by producing mucus through our goblet cells. And alveolar macrophages can also be seen. And lastly, bioactive substrate metabolism. So if you remember our ACE, which is our angiotensin converting enzyme, it converts our ACE1 to ACE2 to lower down our BP. So let's start, no? What is lung ventilation? So lung ventilation or ventilation in general is the movement of air in and out of the lungs through inhalation and expiration. So during inhalation, nagkakaroon ng contraction of our inspiratory muscles to increase intrapleural pressure. So what happens? Nag-i-inflate yung lungs, nag-expand yung chest, no? And during exhalation, that is just the elastic recall of the lung. Meaning, yung elasticity of the lung and the chest allows them to go back to its original position after exhalation. So isipin niyo parang rubber band. So when you try to pull the rubber band, yan yung parang inhalation mo. So like parang hahaba siya or lalaki siya. And when you let go of the rubber band, so parang mag-recall siya back. So parang ganun yung lungs natin. Okay? So what are the muscles of your pulmonary respiration? So your lungs have no innate muscles for it to move. No, it has to rely on the intact system of the chest. So upon quiet inspiration, your diaphragm actually is the one working, siya yung main, no? So your abdominal contents move downward and forward, increasing the anteropostero and lateral diameter of your chest. So upon labor inspiration or force, actually nakikita to during exercise, your external intercostals are the most active. Ayan. And kasama rin na dito yung mga subcostal, levatorus costatum that elevates your ribs and your serratus posterior. Itong supas na naaral ko siya sa board, these are also your accessory muscles that help you during inspiration. So supas, S, the STM, your U, upper trap, P is your pex major and minor, A is your anterior scalene, and your S is your serratus anterior. Next, for quiet expiration, again, it's just passive. No, recoil lang siya or elastic recoil lang siya ng lungs. However, if the patient is or the person is doing exercise or nag-hyperventilate, labored or forced expiration yung nangyayari sa kanya, which the main or the most active muscle in labored expiration is your internal intercostals. And actually important din yung mga abdominal muscles natin, such as your rectus abdominis, internal, external oblique, and transverse abdominis, which helps, which is relevant actually during coughing and vomiting. So try mo umubo, tapos hawakan mo yung tiyan mo. Besides your internal intercostals, your rectus, your abdominal muscles are the one actually working. Next, so uncoupling of lungs and chest wall. So your lungs and chest are inseparable, no? Opposed sila sa isa't isa, creating a negative air pressure, parang vacuum sa loob. So what happens is when the chest expands, the lung expands too. Kasi nga, magkadikit talaga sila. So when the when the lung deflates, pati yung chest mo, liliit siya sa size. So kung makikita nyo here, P is -5, so the pressure here is negative, no? Parang vacuum. So when hindi na sila airtight due to stab wounds or basta mabuta sila, the air flows in, no? Causing a positive pressure. So the negative pressure is lost. So what happens there is your lung collapses and nagkakaroon ng ineffective ventilation. So dito sa side, no, this is an example of a person or a pneumothorax. Makikita mo dito sa left lung niya, okay yung ventilation. But here sa right, dahil nawala na yung negative pressure niya, nahihirapan mag-expand. Actually, yun lang. So, ayan, the lung looks collapsed. So, nagkakaroon ng ineffective ventilation. And we have to remember Boyle's law. Ayan. So, yeah, that's one of the gas laws that we're going to discuss. So, your Boyle's law states that there's an inverse relationship between pressure and volume. So, when you have an increased volume, like inflated yung lungs mo, konti lang yung pressure mo. Kasi the particles are spread apart sa malaking space. So, increased chest volume during inspiration, there's a decreased pressure, while there's during exhalation, kapag nagkakaroon ng decrease in chest volume, nagkakaroon ng increase in pressure. So again, your pressure and volume are inversely proportional. So next, we'll go to the statics of breathing. So our lungs are elastic, no? Elasticity means the tendency to return to its resting shape after being stretched. Example natin kanina is your rubber band. Okay? So pressure gradients are generated across the length of the airway, no? Across the lung substance and chest wall thickness. So let's look at the picture here on the right side. So marami tayong pressure na nakikita dyan, no? So isa-isahin natin. So your atmospheric pressure, ito, it's actually 760 mmHg. Pero dahil ang hirap yung sulating 760, usually sa mga diagrams, you just put PATM is equal to 0. Okay? Next, your alveolar pressure or your intrapleural pressure, intraalveolar pressure, that's actually the pressure inside your alveoli that changes depending kung anong breathing cycle ka na. Next, you have your intrapleural pressure or just your pleural pressure. Ito ay yung pressure sa pleural cavity mo, just outside your lungs. So, again, as we said, it's negative, no? Parang siyang vacuum, suction siya, kumbaga. While your transpulmonary pressure is actually the difference between your intraalveolar and your intrapleural pressure. Okay? So, ayan. So, di ko na siya nilagyan ng maraming text, so just listen na lang to my explanation. So, the first image here, it's an image at the end of an expiration. So, the pleural pressure is always lower than the atmospheric pressure. So, makikita natin dito that the pleural pressure is actually negative. It's lower than 0 and on negative side. Okay? So, second image, at mid-inspiration, when we inhale, the inspiratory muscles make the pleural pressure more negative pa. So, kung makikita mo dito, from negative 5, nagiging negative 8. And alveolar pressure becomes negative. Ayan, nagiging negative yung alveolar pressure mo because nag-expand siya. So, remember, Boyle's law. So, kapag tumaas yung pressure, tumaas yung volume mo, sa case na to, like, expand yung alveoli mo, magiging negative yung pressure mo. And at the third image is at the end of inspiration. So makikita mo, sobrang negative na niya yung pleural pressure mo. So mula negative 5, naging negative 8, and at the end of your inspiration, naging negative 10. It is important to note also na yung first and the third image, which is your at the end of your expiration and at the end of your inspiration, makikita mo that the pressure of your alveoli is actually 0. And the same sa pressure sa mouth. Okay, this is because walang airflow na nangyayari at the end of your inspiration and at the end of your exhalation. Okay, so I hope that's clear. So again, so kapag dito, makikita mo na as one inhales, mas nagiging negative to negative yung pleural pressure mo. Okay, and then the alveolar pressure is 0, equal or same siya with your atmospheric pressure at the end of your expiration and at the end of your inspiration because there is no airflow happening. So upon exhalation, ano nangyayari kapag nag-exhale ka? Di ba? Elastic recoil lang siya. So yung recoil, ito yung force to drive normal exhalation. So the pressure becomes positive since liliit na yung space ng thorax mo, forcing the air out. So in order to really understand this elastic property of the lungs, go back, go back ka lagi kay Boyle's Law. Okay? So, yun yung tip ko. Okay, so, yeah, now we go on to the dynamics of breathing. So, let's try not to get overwhelmed by this figure. Okay? Kung naintindihan mo yung previous slide, maiintindihan mo na rin ito, hopefully. So, I'll break it down for you. So, sinasabi lang dito na once you breathe, no, so yung intrapulmonary pressure or your alveolar pressure decreases when lung volume increases. So, mula 0, since nag-inhale ka, mag-decrease yung pressure niya. As well as your intrapleural pressure mo, bababa rin. Kasi nag-expand yung chest mo. Okay? So, once expiration, meaning air is forced out, so mangyayari is liliit yung chest mo, liliit yung alveoli mo. Ang mangyayari dyan is tataas naman yung pressure mo. Ayan. Okay? Since, ayun. So makikita mo that the alveolar pressure, again, alveolar pressure is at 0. Same with the mouth at the end of inspiration and at the end of exhalation. So ayun. So whenever you inhale, there is a decrease in pressure, and when you exhale, there is an increase in pressure na. Yun ang sinasabi dito. Okay? So next, lung volumes and capacities. So your spirometer is a device that measures only relative lung volume. So ano ba yung relative lung volume? It's actually the volume of gas that goes in and out of your lungs. Your relative lung volume does not account for the amount and distribution of gas. So your spirometer cannot measure your residual volume. Okay. So it looks like a messy slide, but I'll help you through it. So we have actually 4 lung volumes and 4 lung capacities. So let's start with volumes first, no? Siya yung makikita dito sa pinaka-left corner, pinaka-left column. Okay? So meron ako pa tandaan dyan, it's ITER. IRV, tidal volume, ERV, and your residual volume. So ITER. Okay? So start muna tayo sa tidal volume. Ito. So ito yung amount of air that goes in and out of the lungs. Parang tidal waves. Okay? And 500 ml lang siya. So your tidal volume is the volume of your alveoli plus the volume of your dead space, which will be discussed later. Next. So IRV naman, ito yung amount of air na kaya mo pang i-inhale after your tidal volume. So ito yung tidal volume, di ba? Mas kaya mo pa daw i-inhale. So that's your IRV. So kumbaga, ito yung reserve air natin if you want to take these deep breaths pa to cough or to talk loudly or during exercise. Okay? Next is your ERV. Ito. So, ito naman amount of air na kaya mo pang ibuga. So, tidal volume. Ito pa yung kaya mo pang ibuga pababa after exhalation. So, same as coughing. So, if you want to cough, di ba, mag-inhale ka, tapos ibubuga mo siya. So, aabot yan sa ERV mo. Okay? And lastly is your residual volume. So ito yung air actually na nandyan lang sa lungs mo and hindi mo siya kayang i-exhale. It's there to allow gas exchange pa rin kahit you're not breathing. So again, your residual volume cannot be measured by your spirometry. So ito yun. Next, you have 4 lung capacities. So itong capacities, itong 4. So ito yung mga pinagsama-sama mong lung volumes. So when you add these lung volumes, you produce your lung capacities. So first, let's start with your TLC. Ito, total lung capacity. So yan yung total amount or total volume ng air at the end of maximal inspiration. Bali, ito yung addition ng 4 na lung volumes, which is usually 6 liters or 6,000 ml. Ayan. Next is your vital capacity. Ito yung total air except your residual volume. Ayan, hanggang dito lang siya. Okay? And this is easily measured by your spirometry. Again, your spirometry does not measure your residual volume. So your vital capacity, ma-measure yun ng spirometry mo. Okay? Next is your FRC. So ito. So your FRC, ito yung amount of air na natitira sa lungs mo after tidal expiration. Okay? Remember, tidal expiration. So ito pa yung natitirang amount of air after tidal expiration. Okay? And lastly is your inspiratory capacity. It's just a counterpart ng FRC mo, which is the sum of your inspiratory volume and your tidal volume. So, pakitingin na lang ito sa right side of the slide. So, these are parang shortcut ng lung volumes mo. So again, you have 4 lung volumes, your iter, and 4 lung capacities, which are the summation of 2 to 3 of your lung volumes. Okay? So, yan, respiratory tract. So, I hope everyone is familiar now with this, no? So, you have two zones in your respiratory tract. So, you have your conducting zone and your respiratory zone. So, your conducting zone, it's from your trachea to your terminal bronchioles. So, ang function ng conducting zone mo is to transport gas to lung. So, it's a conduit, kumbaga. Walang gas exchange na gaganap dito. Dinadala lang nila yung gas papunta sa lungs mo. So movement of air is through bulk flow, no? And later we will discuss the inverted funnel diagram. And the second zone is your respiratory zone. It's from your respiratory bronchioles to your alveoli, where gas exchange actually happens. So your movement of air here is through diffusion. Ayan. So yung airways natin, parang circuit lang yan. So may mga series and may mga parallel. So ito yung sinasabi kong inverted funnel diagram. Ayan, itong dalawang figures. So yung cross-sectional area ng conducting airways actually increases dramatically until umabot ka sa respiratory zone. So meron din siya mga generations. So yung conducting zone mo is generation 0 to 16, while your respiratory zone is from 17 to 23. So as you go down to the next generations, ang nangyayari, nag-increase daw yung cross-sectional areas nila. Hence, the inverted funnel. So dito, kahit siya yung sabihin mo malaking airway mo, pero actually siya yung pinakamaliit na surface area. Okay? So, actually, mas malaki yung area na pinagsama-sama mong alveoli dito kaysa sa isang malaking tube. Yun ang sinasabi ng inverted diagram. Hence, the increase in area in the surface area is reduction of gas velocity in small but numerous peripheral areas. So, sinasabi lang dito, when we breathe, may mass flow dito sa may respiratory zone natin. Sa conducting zone natin, mass flow yan. So, yung bulk flow or yung mass flow na yan, sobrang bilis or high velocity yan. Okay? But, actually, your velocity drops kapag pumunta na siya sa respiratory zone. Kaya, ang movement ng gas dito sa respiratory zone ay diffusion na lang. Okay? So again, mass flow, high velocity yung flow ng air dito sa conducting zone natin. And then pagdating kasi sa respiratory zone, since sobrang laki na ng surface area, bumabagal na rin actually yung flow or yung velocity ng flow. Kaya ang nangyayari, gas exchange happens here via diffusion na lang. Yun. So, since we're talking about our respiratory zone, so ang bida naman dito actually is your alveoli. So your alveoli are the site for gas exchange. So naaral na rin natin before yung alveolar blood-gas barrier, no? So sa alveoli natin, may two types of cells na may makikita tayo. So you have your type 1 pneumocyte, which accounts for 95%. They're actually flat cells, no? Siya yung nasa gilid. And then it allows, so the main function of your type 1 pneumocyte is to allow gas to diffuse, so gas exchange. So it maintains the integrity of your barrier. While the other type is your type 2 pneumocyte, so it's a secretory cuboidal cell that accounts for the last 5% of your alveoli. It produces R surfactant. So alveolar ventilation is respiratory zone breathing, no? So your alveoli or respiratory zone are not fully emptied during exhalation, and that alveolar volume changes only by 15%. So, di ba sinabi natin na it's not fully emptied in exhalation. So, meron tayong tinatawag na physiologic dead space. Remember, na-encounter natin tong physiologic dead space during the tidal volume kanina sa lung volumes. So, your physiologic dead space, ito talaga yung gas na iniiwan sa airways where gas exchange with blood does not occur. So, important to for conduction ng air, but walang gas exchange na nangyayari dito. So, ito yung dead space, no? So, wala lang, dumadaan lang talaga dyan yung air. But it's your tidal volume. So, your tidal volume, your 500 ml is equal to your alveolar and your physiologic dead space. But actually, yung alveolar lang, ito lang yung nag-undergo ng gas exchange. Yung dead space, wala, nandyan lang talaga siya. For conduction lang talaga ng air. Next is your diffusion. So again, gas exchange in alveoli happens via diffusion. So it is the movement of gas molecules across a concentration gradient. So oxygen moves from a bulk flow, di ba, to area near the alveolar wall and then goes into the blood. Okay, so yung oxygen natin pumapasok sa lung, ay pumapasok sa trachea hanggang sa umabot siya dun sa alveoli natin. So, pagdating na sa alveoli, sobrang laki pa rin ng concentration ng oxygen dyan. Okay? So, from higher to lower concentration, nagmo-move ang diffusion. So, baliktad naman for carbon dioxide, since mas malaki yung pressure niya sa blood than the alveoli, so dito yung carbon dioxide, it moves from your capillaries to your alveoli and out of the lungs. So, kung makikita mo, baliktad sila ni oxygen. Okay? So, ayan, dito papasok si Fick's law of diffusion. So Fick's law of diffusion states that the main driving force is the partial pressure difference, not really the concentration of your molecules. So mas malaki yung pressure ng oxygen dito sa alveoli for oxygen, kaya siya yung from higher to lower. And same goes with your carbon dioxide. So mas malaki yung pressure or partial pressure niya dito sa capillaries. That's why it moves from your capillaries through your alveoli. So factors affecting your diffusion is the thickness of your membrane surface area, your diffusion coefficient of your gas. So ang pinakamabilis actually to cross over barriers or to diffuse is actually your carbon dioxide. Next your oxygen, next your nitrogen. And lastly is the pressure difference of your gas. Hence, the meaning of your Fick's law. So again, your Fick's law states that the driving force is actually the partial pressure difference, not the concentration. Okay? Konti na lang, guys. Okay, so last 5 slides na lang. So bear with me. So next is work of breathing. So there are 2 important principles when we talk about how your breathing works. So it's your resistance and your compliance. So we'll start first with your resistance. So meron tayong tinatawag na total peripheral resistance and nahahati pa to sa dalawa. So you have chest wall resistance that accounts only 10%. So this is actually the energy loss as heat due to friction when tissues and joints displaces the gas flow. While 90% actually of your total peripheral resistance comes from your lung or pulmonary resistance, which is air resistance plus tissue resistance. Okay? So, ano ba nga yung airway resistance? So, airway resistance, it is the energy loss due to friction and turbulence when there is gas flow. Again, when there is gas flow. So, kung walang gas flow, walang airway resistance na nangyayari. Okay? So, ang important matandaan dito that airway resistance only occur when there is gas flow. So, major site of resistance actually happens in your large and medium-sized bronchi. So, lower airway resistance happens after the 4th and 5th generation. So kung balikan nyo kanina yung inverted funnel model slide, di ba sinabi ko na may mga generations actually yung respiratory tract natin. So from your trachea to your major bronchi, matataas pa talaga yung resistance dyan. Because maliit actually yung cross-sectional area nila. Okay? But after lumagpas yung air sa 4th and 5th generation, nagkakaroon ng decrease in airway resistance because of a large increase in total cross-sectional area. So kaya nating sinasabi na silent zone yung mga smaller airways kasi hindi natin sila actually naririnig. And they can actually be significantly damaged na even before na may marinig ka na turbulent flow sa larger airways mo. So dito, as you can see, this is your trachea, highest turbulent flow dito. Kasi it's actually the narrowest as compared to your alveoli, since they have greater surface area, mas hindi mo maririnig yung turbulence nila and hence, less your airway resistance. So makikita mo, mas laminar yung flow nila dito. That's why wala kang maririnig, no? Sila yung silent zones. So let's not forget your Ohm's law. Your Ohm's law states that the relationship between the air flow and pressure is described by the resistive properties of your lungs. So again, the larger the airway, which is your trachea, the higher the resistance. Next is your compliance. So your compliance is the ability of your lungs to change volume for a given change in pressure. So isipin nyo naman ngayon that your lungs is like a balloon, no? So your balloon, it complies by expanding kung may air pumapasok sa loob. And then it deflates if nawawala. So it's really about, compliance is about how giving the lungs rather than how stiff it is. So now let's talk about surface tension. So ito yung tension or force caused by water and air interface. So malakas yung force nila, malakas to yung force between your water and your air, causing a decrease in surface area. So ito yung actually nangyayari sa alveoli natin. So since the gas exchange happens, may contact yung air and yung liquid, causing the alveoli to have decreased surface area. So when air-filled lungs actually requires more pressure to inflate lungs kasi may surface tension between your air and fluid interface. Ito yung sinasabi nung picture na to. So parang kinumpare daw nila yung compliance ng lungs sa isang saline solution and sa air, makikita daw na saline lungs is more compliant due to lack of surface forces. Kasi water-water lang sila. As compared kung water and lung, nahihirapan dahil nga sa surface tension kasi sobrang lakas ng force na nagka-create ng water sa ng air. Huh? So, at ito yung sinasabi ng law of Laplace na the smaller the bubble, aka or alveoli, the more pressure is built inside. Okay? So, magtataka ka, bakit hindi nagko-collapse yung bubble or yung alveoli mo kahit na mataas yung pressure sa loob? Tada! It's your surfactant. It's because of your surfactants. So your surfactants are the ones that prevent your alveoli to collapse from its high pressure. So, nire-reduce ng surfactants actually yung surface tension or dinidisrupt na yung surface forces between the air and your water. So, di ko na ipapronounce yan, but basta si DPPC, yan yung most active and main component ng surfactants mo. So, or smaller alveoli, sila yung pinakamaraming surfactant kasi sila yung may highest pressure and highest tendency to collapse. So, ayan. And last but not the least, slide, ay hindi pa pala. O tama, ito na pala. So, again, your minute ventilation. So, minute ventilation is the total amount of gas that moves in and out of your lungs per minute. So, ang ano niya, tawag dun, na-mental block ako. Basta L per minute siya, liter per minute. Okay, so minute ventilation is liters per minute. So it's yung equation niya is minute ventilation is respiratory rate per 1 minute times your tidal volume. So ventilation, tidal volume. So alam naman natin na ang tidal volume is like around 500 ml. Diba? So its tidal volume is your volume of your alveoli and the volume of your dead space. So lower respiratory rate means there is higher tidal volume and higher elastic work. So higher elastic work is working against compliance. So elasticity and compliance are inversely hindi mo inversely proportional, but magkabaliktad sila. So compliance, ito yung how giving, elastic, ito yung ability na bumalik agad after being expanded, kumbaga. While a higher respiratory rate means there's higher flow and resistive work. So, mas mataas yung, higher yung resistive work or yung movement against your tubes. So, ayan. So, ito yung diagram to show it. And, yeah. I think this is my last slide. Hindi na ako nakapag-thank you slide. So, ayun. I hopefully may naiintindihan kayo. Sorry kung sabaw, but, ayun. Again, so, you can go back naman dun sa mga slides na sa tingin nyo na, or sa part sa tingin nyo na kailangan nyo siyang himayin. ayun lang. So I hope you guys learned something today. And good luck. Thank you.